This chapter introduces you to a new data structure called an array. An array is similar to a vector in that it holds multiple data values of a single data type. Unlike a vector, an array's size is pretty much fixed from the time you declare the array. There are techniques for changing the size, for making it larger, but they're beyond the scope of this course, so for the sake of this course, we're going to say that an array size is fixed. Another difference between an array and a vector is that an array can store data in more than just a list format. So for example, if you have rows and columns of information, such as in a table, you can store that in an array. You can also store more than 2 dimensions in an array, but for this course we'll just stick to 1-dimensional and 2-dimensional arrays. Let's start our discussion by demonstrating how to declare and initialize arrays. An array declaration begins with the data type of the values being stored in the array. So if we want to store integers in an array, we'll begin with the keyword int. That's followed by the name of the array, followed by the size of the array, which we put in square brackets, like so. So in this declaration, I'm saying I want to have an array of 10 integers, and we're going to call that array numbers. To initialize the array by putting values into it, we can just write a simple loop where each value of I can be stored into the array, like so. If we want to store 10 numbers from 1 to 10, then what we'll do is we'll use direct access, similar to how we do direct access with a vector, and we'll say each value of I plus 1 will be stored in the ith position of the array, so that the first position of the array, 0, will get the number 1, the second position, 1, will get the number 2, and so on. To see how that works, let's write another loop, just like the first loop, and we'll display each item in the array and its position. So we're going to write cout I, followed by a colon, followed by the array element itself, followed by an inline. Let's build and run that short program. Oops, little mistake there. Put two operators, let's get rid of 1. And there we see we have the 0th position stores 1, the first position stores 2, and so on and so forth until the last position, 9, stores the value 10. The first position in an array is called the lower bound, and the lower bound always has to be numbered 0. The upper bound is whatever the position of the last element is, and it can vary, of course, depending on the size of the array. But the upper bound is always 1 less than the size, so that if the size of our array is 10, then the upper bound is 10 minus 1, or 9. Another way of declaring an array is by writing what's called an initialization list, which includes the elements you want to store in the array. I'll demonstrate that by first commenting out the code from before, and then begin with a new declaration. We'll use the same name. And this time we're going to leave the size blank because we're going to let the compiler determine the size from the initialization list. An initialization list is a list of data values that starts with an open curly brace, ends with a closing curly brace, and has a comma delimiting each data element, so that this list consists of 1, 2, 3, 4 through 10, with each element separated by a comma. We can verify that this works by using the same loop we used before. We'll just copy it back into our program down below. Now let's run the program. And there we see that we accomplished the same thing using an initialization list. Another way to declare and initialize an array is to use an initialization list and a size, and not to specify all the values in the initialization list. Let me demonstrate what I'm talking about. Here we're going to create numbers again. It will have 10 elements in it, and we'll write out the first 5 elements, 1, 2, 3, 4, 5, and then we'll stop the list there. What will happen is, for the other 5 positions, the compiler will fill in zeros, which is the default value for the integer data type. Again, we can verify that that's correct by looping through the array after we're through with the initialization list. So let's take a look. And there you see how that works. Position 0 gets 1, position 1 gets 2, position 2 gets 3, position 3 gets 4, position 4 gets 5, and the remaining 5 positions get zeros since we did not specify them in the initialization list. Those are the 3 ways you can initialize arrays. In the next lesson, we'll talk about how to access array values using loops.